Okay, one point I was talking about the traditional serotyping use anti-sero, and we are now doing the PCR. Okay, what is easier or what is useful? It will depend on the condition of your country. For example, I think now it's more easier you make a primer and got the reagents for PCR, then you got the antiserum for all the types. Of course, PCR are not enough for all, but the main serotypes you can work. Okay, just to finish, maybe I will. If you permit, I will not make the electrophoresis today of that to save the time on the noon to use start the lamp directly. Okay, just to discuss the result here. Another one I put on the tables. Okay, I make that paper ditch. What you make is you make the common TSA or even the nutrient agar, and then you put some sterile filter paper strip by 0.5 centimeters for 3 centimeters, and 0.5 you make a ditch, and you put crossing the filter paper, and you put the antiserum for phase 1 in here in the middle, and then you inoculate your sample here that you know already the phase 1, which one is, and then by the overnight culture, the bacteria will cross the ditch by the filter paper, and the second phase 1 will come to this side. So you pick up from them, and then you make the same for the second phase. Okay, that is the ditch method. What they say that the good for the ditch method than the swarm plate or this usually using the Craigie tube is that you can save your antiserum. You can just use 0.5 microliters. They say it's enough to 0.5, no, around 5 microliters of antiserum. It's enough for that. Okay. And then, what will be the result for the PCR that you're doing today? You will see results like this, okay? And as it is a multiplex, you need to check the size. For example, for this side, around 200 and something will be enteritis. The other will be titanium, and the other will be hardware. You'll see like this. So you need to check the bands you obtain, the size, and you have for the phase 1. By using this multiplex, you just have this for the O antigen, what the group 1 did today. So you need to see these results, and after these results, you need to go to the second step, that is, what is that? For phase 1 flagellar antigen, what the group 2 make today, okay? And then you need to go again to check which side of the band you have, okay? So, for example, for this, you have on the line 3, you have the bands for enteritis, that is the G and M, and for line 5, you have the serotype hardware, and for the band 8, you have for the serotype titanium. Okay, so you need, and then you need to go to another PCR that is for the second phase 1. Okay, second phase, and you have to check again which one. In this, what we work today, you have only 2, the serotype 2, Okay, that's it's around 500,000. And the number 8, that is for the harder. So even you're doing the multiplex PCR, you need to make 3 PCR. So does it's less work than normal serotyping or not? How do you think for you? Well, maybe one point good on making this one is that you can obtain the result in 2 days instead of the normal one. If you make the normal way, from here you'll take around 4 days, at least 4 or 5 days to finish that. So for the convenience of time, maybe PCR is very nice, but it's not 100 also. So sometimes you need to repeat the normal anti-serum. Okay. And going to the next step. The next step, what is that? For isolation of salmonella, depend on, for example, on NIH Japanese science for isolation of salmonella, especially from food. What they recommend, they use non-selective pre-enrichment on buffer peptone water, and then you go to use a tetracyanate broth, 1 milliliter, and Rappaport for selective enrichment. And then you choose the ones that it's based on the H2 production of salmonella. But you know that there are some salmonella like cholera suis that do not produce H2S hydrogen sulfide. So you need to use another one, okay? And even some it's rare, but some strains that usually produce hydrogen sulfide sometimes do not produce. So you use the combination of other ones. I think, and for example, for the WHO, non-selective is the same, but they are doing Rappaport the same, but some XLD and BGS combination. And dependent on, and the other, the FDA, XLD, BSA, or hectoin, enteric agar, the combination of some of that, okay? They recommend the combination of those agars. And for Campylobacter, usually you use CCDA or some Butler or Preston or Skilo agar, okay? Like this on the ratio, also almost the same. And I had prepared this for the checking. Please see first the Campylobacter on this MCCDA agar, especially the fetus. Campylobacter fetus on MCCD agar and blood agar, it's grown well today. So you could check it, please. And because it's just selective, but it's not, there's not specialist things to distinguish Campylobacter from the other bacteria. Just that MCCDA and Butler are highly selective. And on the MCCDA, you can see a little grayish colonies on MCCDA. You can open it to see it. Please just take care to do not touch the bacteria. Okay, and you can see, I'm sorry, for the blood agar, the colonies don't grow well today, so it's very small colonies. So you can check, but you can check how it looks like in each medium, okay? That's one point. Another point. Okay, take a little bit time to some needs to check those about the Campylobacter, right? What is E. coli, Salmonella typhimurium, and Salmonella cholera suis? And the media is ES2, DGS, McConkey, DHL, and MLCB. Okay?
Don't worry.
If you see, please look for the DHL. DHL. The DHL is more for a gram-negative bacteria, especially Enterobacteriaceae, gram-negative bacteria. There is the it inhibits the growth of most of the gram-positive bacteria. So most of the it's probably what you got is gram-negative bacteria in that media. And what there is special in that media, if you see the E. coli, there are the same on 4 groups. You can see on 1 and 3 and 4 and 5 groups, you can see the same one. If you see the DHL, if you see the Salmonella typhimurium, it will be a black color colony on the center and transparent on the side. What is that? It's because it produces H2S. Hydrogen sulfide. Okay? So it comes black. But the Salmonella cholera suis do not produce that hydrogen sulfide. So it comes a little bit transparent.
Why?
Because reaction with the H2S react with the iron in the DHL, and it comes a black colony. But because cholera suis do not produce H2S, it doesn't react this black. It doesn't produce this black pigment. Okay. And another point you can see that is E. coli. It's red in the DHL. On the DHL. Why? DHL have lactose and dextrose in that. Okay, so E. coli can use that, and also there is a pH indicator that it's neutral red. That when comes acid, it comes red. So the colonies come red. But Salmonella can't use those sugars, so that it comes colorless. Okay, that is the DHL. Okay, another one that is the MLCB, the pulpo one, the pulpo media. Okay, the E. coli doesn't grow well on this media. If you see it doesn't grow well on this media. This media is made specially for isolation of Salmonella. Okay, and as the DHL, it comes the Salmonella that produce H2S comes black. But if you see the Salmonella cholera suis, it comes a little bit, how to say, purple to brown, to blue to purple, because it do not produce H2S. And also the E. coli doesn't grow well, but it looks a little bit similar. Okay. So another media for Salmonella is the ES2, the one that has the pink colony, one a little bit transparent that has pink colony. Could you find the ES2 media? Pink. Did you find the ES2 media? Right? Yeah. This also for salmonella, isolation of salmonella, but it do not depend on the sugar. It depends on some enzyme reaction. And salmonella comes pink on this media, and the other bacteria like E. coli comes bluish. Okay. Another media is BGS. BGS also has the lactose in, and as salmonella cannot use that, it comes the media, the BGS media comes pink or red. Okay, and the one of the E. coli, because it's used the lactose, it comes yellow. Okay. Let me check. I'm telling this right for BGS. BGS is brilliant green salt agar. Okay, you can check later here. There is the lactose and saccharose in there. Because salmonella cannot use lactose and saccharose, it comes pink. Because the other, it's opposite to DHL. The pH indicator is phenol red. Phenol red and neutral red respond exactly the opposite, right? Phenol red, when it comes acid, it comes yellow, and when it comes not as neutral or near neutral, it becomes red. Okay. And the other media is McConkey, you already know, I think. Okay. And the other three I prepared, it's from isolating E. coli. If you check, there is the ECC, E. coli chrome agar, and chrome agar O157, and SMAC, sorbitol McConkey. ECC it's used for isolating E. coli. E. coli comes a bluish color. Okay, that three use the two chrome agar. Use the enzyme-based color difference. And sorbitol McConkey is based on the use of sorbitol or not, because most of E. coli O157 do not ferment sorbitol. Okay, most, not all, do not use sorbitol, the sugar sorbitol. They can't use. Why? It is by the mechanism of the body. Okay. So on the ECC, what it's a little bit surprised. It's O157. Okay, it's E. coli, but it doesn't come bluish. So when you're using ECC media, you need to take care, because if you think the bluish will be E. coli, you will lose the E. coli on 1.7 on the ECC media. Okay? Because E. coli, the media say what is E. coli is the bluish one that makes the hollow, bluish hollow. Okay? And the chrome agar O157, the colony of O117 comes a little bit purple, and the normal E. coli, it's just uncolored or less colored. The 157, it's specific for 157, and you can get it. What's the problem of these two media? It's very expensive. It's 4 or 5 times the common ones, like DHL and ES2. And the ESMAC is said that the E. coli, a normal E. coli that ferments sorbitol will come a little bit reddish or a little bit purple. And 0107 that usually do not ferment sorbitol will come colorless. But I think if you see it will not come used to that, you will have some questions. Which is which one? Okay. So that's the medias we prepared for you today. Okay, please check it.